I think we'll start. There are no more people to come. Okay, so after a gap, you can start the recording. So today we are going to see the best biometric that is available today, the iris recognition system. In the last class, we saw the retinal recognition systems. We saw three. We saw physiological biometrics like retina. We saw the fingerprint, which are very good, and we also saw several behavioral biometrics like typewriting pattern, the typing pattern, the signature, and we saw the speech recognition. And I also told you that almost universally the physiological biometrics are much better. I told you in that retina is excellent and an excellent biometric, so as to speak. The iris is even better. I told you that the iris the retina is basically a blood vessel pattern at the end of the eye, which we convert into a code. Whereas the iris, on the other hand, this is the iris. All these are different types of irises. You can see the different colors of the iris. The iris, on the other hand, is basically a kind of tissue which is covering the pupil. This black thing you see is the pupil of the eye, the lens of the eye. Covering that, you have what is known as a thick layer of tissue with several patterns and several layers also. There's a stromal layer, there's an epithelial layer, there's a couple of layers, but this is basically a pattern that covers the pupil of the eye. And this is actually the advantage of this iris is that this pattern, this tissue layer, epithelial and stromal tissue layer, is never changes throughout your life. It is almost the same. And it doesn't suffer from scratches, abrasions, grease, dirt, and other things at all. It is and even if the person is a blind person, the iris is the same. It doesn't matter, because the iris has very little to do with the sensing of light and the actual sight, so as to speak. Whereas the retina is very important. The retina for a blind person will be useless, because retina is basically consisting of rods and cones that sense the light, and here there is that issue of the sensing of the light is not there, and that is why even for a blind person the iris can be used, and it is basically a tissue that is covering the pupil or the black part of the eye. Now, the only algorithm that used by iris is based on this Gabor wavelet. It was given by John Daugman. Even today, I think that is the only iris recognition system, and all other companies which are using the iris recognition system are licensing it from this Iridian Technologies that is owned by John Daugman. Iris does not change with age. It is stable. It doesn't matter if you are a blind person. It does not suffer from scratches, abrasions. And another very important thing is that there is no contact. You are not touching it. It is only a lens that is going near the iris. There is no physical contact. There is no distortion. It doesn't matter with respect to the. So these are the other and more advantages are there. Very little. They are very accurate. There is less computational requirement. Memory requirements for the iris code or the template is very low, and so on and so forth. So these are the advantages. Now, what actually happens in the iris? This is the iris, and here you are having circular boundaries of the iris. The outer boundary and the inner boundary of the iris is there. And what actually happens is that this pattern, so as to speak, this this pattern, so as to speak, it's a series of images, as you know, and these are basically converted using a Gabor wavelet into a value. You get a value, a scalar product by taking the image of that pattern and multiplying with a Gabor wavelet, and you get a value, a scalar product. That result or that value is basically a complex number. From that complex number, it is converted into 2 bits. The modulus is thrown away, and the phase is converted into 2 bits depending upon the quadrant, and you get what is known as an iris code. Iris code is basically 2048 bits which describe each iris uniquely. Now I'll again explain. You first decide the circular boundaries of the eye, then that boundaries are known, and this complete imagery of that pattern, which is stroma and epithelial tissue, that images are taken field by field or pixel by pixel. They are converted into a complex number using a Gabor wavelet transform, and that complex number is converted into 2 bits, and this 2 bits is basically added with some operations are happening. The modulus is thrown away and the phase is converted to 2 bits, and then you get what is known as an iris code of 2048 bits, which describe each iris very uniquely. Now, how do you compute the differences between 2 irises? Is through what is known as a Hamming distance. In a Hamming distance, there is a 2048 bit code. So you have given your iris first to the system. The iris is stored and converted into a iris code of 2048 bits. The next time you are giving your iris, and how does it compute or calculate? It does an XOR operation between the 2 codes and finds out how many bits are different and the total number of bits. Ideally, there should be no bit different because it is the same person. But if the Hamming distance is high, that means there is a number of bits that are different. That means it is a different iris. So based on this, it is given. So the Hamming distance should be less than 0.33. Then the chances of the 2 codes coming from different irises is 1 in 2.9 million. So that is the accuracy of the iris code. It is that accurate. The Hamming distance should be less than 0.33. And how do you get the Hamming distance? The Hamming distance is given by the number of different bits from the first and the second iris code and the total number of bits. And normally it will be very less because same iris, there is no change. There is no short sight, long sight. There is no aberration. There is no cataract. All these problems are not there for the iris, and that is why it is the best kind of biometric that is today available. However, there are some disadvantages, so as to speak. You need to acquire from a distance. It's a small target, so you need to be careful and accurate when you are giving the image. Suppose there is a moving target, there is a problem. Then there are problems when you are using the spectacles. You have to remove your spectacles. Then this eyelashes. You do go to a beauty parlor and or a salon and do some touching upon your eyelid, eyelashes. These become problems for that, and so on and so forth. So these are some of the disadvantages, so as to do it. But by and large, this iris is the best biometric that is available. Most stable biometric, doesn't change with age. No contact. It is you're not touching anything. You're not having any problem due to diabetes or occlusion or any other disadvantage disorders. No problem is there. It doesn't change with age. It doesn't change with any other issue. And it is also not concerned with the actual sensing of light. Even a blind person's iris can be easily used as a biometric, whereas a blind person's retina cannot be used as a biometric. So this is the best biometric that is available. You can please stop the recording.